if we were to dissect a rabbit of the animals that we have dissected, we would expect it to most closely follow the phylogeny of a rat. We would predict it to have similar respiratory, digestive, and reproductive structures based on the fact that they are both mammals. We can understand that they're going to share a lot of these complex systems and follow a lot of these different traits. So we would expect to see that these animals would have similar mouths. They're going to have similar teeth, differentiated teeth. The food is going to be eaten and mechanically digested by both of these animals, starting with the mouth being bitten into pieces and chewed, and then passed through the esophagus. And this will pass into the stomach. We're going to see it enter the stomach and then through the intestines. One of the things that we're going to notice between the rat and the rabbit, the rat is going to be in urban settings, and it's going to be eating a lot of really dirty and gross kinds of food. So it's going to need a very strong cleansing organ, and that's what we're seeing with this gigantic liver that it exhibits. Obviously, going through the rest of it, we're going to be seeing kidneys and other similar organs inside of the animals, but we're going to move on to the next system. We're going to be seeing, a need for a chambered heart. We're going to need lungs that can take up air quickly. These are going to be animals that have high metabolisms. They're going to be needing the ability to, access high metabolic functions. We would also expect to see that in these animals, this one is a male, so we're not going to see mammary glands, but they're both going to have penis, testicles, vaginas. They're going to be receiving internal fertilization and birthing of animals, and they would both be using mammary glands to feed those animals. So we know that livers are mechanically breaking down lipids, but we're going to be seeing a lot of chemical digestion with this rat's system, but that's not the case for all of the animals. The earthworm, is going to have a crop and a gizzard that's going to really grind up and mush that soil and kind of extract any nutrients that's inside the soil there. And that's going to differ from the perch. The perch is going to have a stomach that's specially adapted for this purpose. It's going to be, obviously it's going to have the mechanical breakdown with this jaw that gives it the ability to mechanically break down food, but it's going to have a stomach that right in here that allows it to hold food and let it break down chemically. We're also going to see a big difference in the respiratory systems. This fish is going to have these very distinct gills that it's going to be using for gas exchange, and it's also going to have this two-chambered heart, whereas the rat is going to have this four-chambered heart, and the worm isn't even going to have like a distinct heart. It's going to have these aortic arches, and this is going to be different from the crawfish that has these gills that sit here in its legs, and they move in conjunction with its legs, and that is going to expose it to water better and better enable gas exchange. Speaking of the crawfish, it's actually going to have this very cool stomach that has teeth on the inside of its stomach to grind up food. But all this is going to differ from this squid who hunts using these tentacles, and it has a closed circulatory system very similarly to the rat. And it's going to have this big mean beak on the inside that's going to be used to not only take in food, but kill it and mechanically break it down into smaller chunks. And it's going to also have these gills, and it's going to have multiple chambers of the heart that it's actually going to have three different hearts, one that is a systemic pump, but the other two that pump directly for these gills so that it can have a fast and efficient gas exchange. We're also going to see that all of these animals have adapted to have a reproductive system that best suits their environment. These worms are hermaphrodites, right? They have the ability to just mate with any other worm. They can take in sperm and create the worms make a almost like a cocoon that pulls fertilized eggs off of the body and holds them in a suspended, almost like gel. I believe the word's cocoon. But comparatively to a crawfish, which has very distinct male and female genders, and the crawfish is actually going to hold the egg on its body. It's external fertilization, but it holds the babies onto its body nonetheless, comparative to the rat that actually is going to internally hold the pups on the inside of its body. This is more metabolically intensive, but the rat has the ability to handle that. Whereas you have an animal like a perch where its body and activity levels depend on the external environment. It's much easier for it to do low investment, spray your babies everywhere, and it'll land on some eggs outside of its body. This is going to increase the probability of offspring survival despite the lack of parental care. But the rat is going to have that internal embryonic development. And so, this is going to be a common strategy among mammals where finding a mate is more assured, but the energy cost per offspring is higher. And speaking on the energy levels and the activity levels stemming from the ambient temperature, one of the big things that we're going to be seeing a difference in is the rat's metabolism is going to increase to produce more heat, right? So it has these features that are going to help enable it to stay warmer and help adjust itself, like this fur. If you were to hypothetically swap the purchase physiology into a rat or give it similar traits, the rat is going in between all kinds of different temperatures and weathers and different conditions. I mean, just here in Arizona, if it's up north, it's got to deal with snow and rain. If it's here, it's got to deal with, drought and heat, or, living in the sewers or being, around houses. The ability to have this, changing system where it can adjust and maintain its own heat and homeostasis and not have it depend on its outside surrounding allows it to adapt and overcome the multifaceted environments that come on the land, even just between, an hour's distance. Whereas the perch is just going to be sitting really in the same kind of water environment. It's not going to need the high pressured system to move around. It can be okay with its, very passive diffusion ability in its circulatory system. It's not going to need all the extra chambers of a heart to be effectively pumping blood when it's not having a demand for that metabolism. I mean, there's a plethora of reasons, those being some of the reasons why you're going to see a perch being exothermic and a rat being endothermic.